for coming today, and thanks, Vino, for inviting us. I'm really super excited to be in India for the first time ever, and I'm sure it won't be the last time. So yeah, I'm going to talk today about the neuroscience of music. So, okay, I'll start by saying a few notes on this field. For instance, we know that music is rewarding. It's a nice experience to play, we know that, to listen to music, to improvise, but something else is going on when we, for instance, listen to music. We have a very powerful response, physiological, emotional, and behavioral. And since the early 90s, we have the possibility to look at the brain thanks to the neuroimaging methods that became widely available. So there's been a huge amount of interest in brain and music, like what goes on in the brain when we are engaged in musical activities, such as listening or playing, at the time of doing those activities, but also what are the consequences in the long term of practice. And so what we have learned so far is that, for starters, there's not such thing as a music center in the brain. So there's not just one spot where music is processed, but instead we could talk about a music network. In fact, when we just listen to purely instrumental music, like no words, no processing of meaning or semantics, we see widespread brain activation, as you could see with the video that Vino played before. Listening to tango activated areas in the forebrain involved in abstract thinking, also areas involved in spatial cognition, and deep areas of the brain involved in more emotional processing. So this means that different mental processes are engaged beyond emotion or just audition. So engaging in music listening is a powerful way to activate most of the brain. Now, the most provocative discovery in this field is that expert musicians have different kind of brain anatomy and function than non-experts. For instance, string players have greater cortical area developed to the sensory motor control of the left hand and left fingers, which makes sense because that's the hand they use for specialized fine-tuned motor movements. The musicians also have been shown to possess greater cortical thickness, and also seems that the corpus callosum, which is the area in the brain that connects two hemispheres, seems to be larger in musicians. Okay, now the idea that musical training alters the brain is not a new idea. About a century ago, this gentleman, Ramon y Cajal, considered the father of neuroscience, predicted the implications of training and experience on the brain, and he had the intuition that this process would be pronounced in musicians. And this happens because the brain is plastic, is flexible. And in neuroscience, you hear about brain plasticity because the brain is capable of changing itself. The brain has changed across evolution to adapt to the pressures of the environment and the physiological demands, but it also changes within our lifetimes in a smaller scale, of course. So in this talk, I'm going to show you the usefulness of studying music and the brain, how musical training can produce changes that we can measure, and what's more interesting, that these changes we can observe while the brain reacts to music, while we listen to music. So first, I'll justify the value of studying music and musicians in brain research. Then I will explain some of the experiments we have been carrying with Vino and Petri and other collaborators in Finland to study the effects of musical training on the brain while during listening. And we'll go through the main findings and contributions of these studies. Okay, so neuroscience, as you know, is all about trying to understand what it is to be human. And music has something to say about almost every aspect of human brain functions, such as perception, motor control, cognition, different types of cognitive abilities like learning, memory, planning, prediction, and of course emotion. And music taps on all these functions because there's a lot going on, as you know, at once when we engage in musical activities. For instance, music is complex at several levels. Music requires a high degree of auditory and motor precision. Music engages different systems at the same time. which demands high parallel processing between them with a special strong interplay between action and perception. And it would seem that compared to other types of training, the effects of musical training can transfer to other domains to a greater extent and faster. So all these unique properties of musical training make very difficult to find comparable activities that can produce plastic changes in the brain. Now, even though music has been with us, with humans, for a long time, in evolutionary terms, only a small proportion of us become music experts. And they become music experts through a lifetime of intense and repetitive sensory motor training, and often very early on in life. So this is what makes music and musicians such an ideal population to, convenient as well, to study the brain adaptations driven by experience. So we could say that music is to the brain what physical exercise is to the body. And so it's a resource that tones the brain for auditory fitness. And as you heard in Bino's talk, more and more evidence emphasizes that music is biologically powerful, or as Patel puts it, a transformative technology of the mind, because it has such unique properties in terms of its breadth throughout the nervous system that it can produce plasticity in many, many areas simultaneously. Now, at the same time, you may ask if music has such a strong impact on brain plasticity, could we use this effect to tap on specific brain systems and potentially improve physical and psychological health? We have seen some examples of that. So there are already applications in this direction. For instance, music seems to be very powerful with inducing memories and movement. It helps recall autobiographical memories in those with dementia, so it gives them a way back to their own identity. It also helps in Parkinson's patients to initiate movement with patients with motor disabilities because of that link that Petri mentioned between rhythm and movement. So, which is a fascinating thing in itself. Also, if you take, for instance, words or phrases and map them onto, or embed them into a melody or rhythm, it can facilitate speech in those with communication problems. And because music is so engaging and enjoyable, it makes it a very efficacious therapy. So that's why it's not surprising to hear about the healing power of music. But exactly which brain mechanisms underlie all these effects, we're only starting to figure out based on the knowledge that neuroscience studies contribute to. So yeah, a better understanding of these mechanisms could be used in clinical settings to improve the life quality of such patients. Also, the emotional aspect is very important, and it's very puzzling as well. So how does music produce such emotional responses in humans, driving us from euphoria to despair and everything in between? So we all know that music can do a lot for our mood. It can boost our arousal levels, and as a matter of fact, we, unconsciously or not, use it to regulate our mood. So this promotes, again, physical and psychological health. We use it also to relieve anxiety or even pain, as Vino mentioned. So yeah, the field of music neuroscience can give insights into these and other questions. For instance, why music is so ingrained in human species, for instance, to start with. And also not so much other animals in this planet. So